Okay, so what I've gone ahead and done is remove the little bit of manual trace work that we did earlier, and I've took the PCB back to rat lines only. So we've got no copper tracks here. Yeah, we've got some silk screen text, but that should be fine for this. And what we're going to try now is to convert this using an AutoRoute piece of software, an AutoRouter. So the first thing we have to do here is to export the PCB. Export as a Spectra DSN file. We've got various export formats, but the one we're interested in that we need is Spectra DSN. So let's do that. Let's export it, and I'm going to call that 6502 V2 card because I've actually got an earlier version of this called 6502, which was actually version 1. So this is version 2. So we export it as a DSN file. We'll click save, and yes, I want to replace it. Right, okay, so that's done. So we've exported what we have here, the PCB footprints, the component footprints, sorry, and all of the rat lines and everything. That's now been converted into a DSN file. So let's go and have a look at the AutoRouter now. Now I've got a folder here that I've prepared already on my desktop. You'll notice there's the file. We've now got 6502 V2 DSN, which is the file that we've just exported from KiCad. The interesting, important part here is this file here called FreeRouting.jar. Now, this was written a while ago, and it's a Java application that you can download free off the internet. It's slightly tricky to find. There's not just an obvious site, and I'll try and include a link to this. Let's move on. So you need to have something on your computer which enables you to run this, because it is a Java application. So you need to have the Java runtime environment installed on your computer, which is free also to download. So once you've got the Java runtime environment installed, which is quite quick and painless to do, once that's on, we can operate with Java files. So let's double click this and open it up. Okay, it's asking us to load in the DSN file that we've just created from KiCad. So let's find that. Yeah. So on FreeRouter, we've got the version 1 and we've got the version 2. So it's version 2 that we want. So let's load that in right now. Right. So what we've got here is the board layout that we've exported from KiCad. It looks slightly different. It's a bit darker. The colors are a bit darker, but essentially it's exactly the same. We've got all of the footprints, and you'll notice all of the silk screen and all the reference numbers and value numbers, they're all gone, because now we're only concentrating on copper tracks. This is what this is all about. And you'll see we've got plenty of rat lines. It knows where things have to be connected. It kind of knows what it's going to do. And what we have to do now is actually quite simple. We tell it to AutoRoute. Select AutoRouting, and off it goes. And this is quite nice to watch. The AutoRouting Java application is looking at the rat lines and determining what the best path is for the copper. Now I've got this set for the default track thickness, and I find this is actually the best way to work, is just let the thing do it using thin tracks to start off with. When we've finished, this will be pulled back into KiCad again when it's done this process, and you can change manually the thickness of the tracks after that. So this is saving a lot of man hours of routing, and it's also doing it probably more efficiently than what a person could do it, maybe, depending on the skill of the person doing it. So I'm quite happy about it, that it's just doing it all automatically. And this process takes a lot, it takes a while. I think it takes about half an hour or something like that. So you'll notice that it draws a track, and then it thinks, oh, maybe it's not right, because now I can't draw the next track. It's going to cross out or short out or something. Changes its mind, it goes back a step, tries it again. So it's running an algorithm to discover the best path and the best efficiency for the connections. You'll notice we've got these going on as well. These little yellow dots, these are vias, where it's decided I need to connect the top trace to the bottom trace, because it couldn't do it any other way. And what you'll find is it's trying to make the board with as little amount of vias as possible. It's always better if you've got no vias, but you usually end up with some of them at the end of the day, and it's totally fine. It's just better if you don't have them from a reliability point of view, I think. What you'll find is those vias will appear like they are now, and maybe as the board design progresses, as the algorithm runs through the traces, it will decide, oh, I don't want that via there after all. It'll either delete it or it'll move it to another position, which is kind of what it's doing at the moment. It's checking out the via positions and going, can I get rid of that via? If it can get rid of the via, it will do so. The red traces, just like in KiCad, are the top copper layer. The blue traces are the back copper layer. And you can watch this and just enjoy the view until it's finished. Go away for a cup of coffee, whatever. So what I'll do is I'm going to edit the video and we'll let this finish, and I'll show you the rest of the process once that's done. Alright, here we are back again. What happened was, it's been running for about an hour, and it seems to have got stuck in a loop where it wasn't really making any headway. It had finished routing all of the tracks. I've seen this happen once before, but usually the program will stop itself and when it's satisfied that it's finished. And who knows, if I left it run for another hour, it may have actually come to that stop itself as well. So I've interrupted it, and we'll see how this goes. I think it's actually done as good as it's going to get it. Who knows, I could have let it run for longer. Okay, so we've ended up with a via count of 10. That's those little yellow dots here, and it looks pretty good, not bad. So it looks like it's finished it. So what we need to do now is export this as a Spectra session file. This is the format that we're going to need to pull back into KiCad. Okay, so let's do that. And I believe that was it. So let's get back out of there. We should have, there it is there. This file here is the one we've just created, which is 6502 version 2 card.ses, which is the session file. And this is the file that we're going to pull back into KiCad. So let's do that. Okay, so that's our ratline version that we started with. Okay, but now we're going to import Spectra session file, which is this one here, Spectra session. Yep, so there's our saved v2 session file. So let's open this up, and now, as if by magic, we have tracks. Let's have a look at this, and on closer inspection, let's have a look. Some of the power rail tracks look a bit thin, but they are copper tracks. There we go, and it's neat. I mean, it looks pretty good. So that AutoRoute process took care of all of the routing of the tracks, both the top side and the bottom side copper. The only thing I haven't done here is put in mounting holes, which I need to probably, I hope I've got room there, and probably should have done that earlier. So we need to have some mounting holes for the corners, some through plate holes. But basically that's turned out reasonably good. You can see here we've got copper track going through between pins, and then we hit a via here, then it continues on the other side of the board, and it goes down to this pin 13 on that chip there, and so on. So yeah, it all looks pretty good. Now what we can do here is we can do a check, design rule checks, and let's just see if we've got any problems here. So let's run that, run design run checker. We've only got one warning. That's not too bad, and basically all it is, it's warning us that the silk screen is clipped by the solder mask. So, and it's reference C10. Where's C10? Something clipped on the, oh yeah. What's happened here is, on C10, you can see that the reference number here, C10, okay, is clipping onto U4, so you wouldn't actually see that. It would be underneath the chip, in fact. So what the warning's telling us is this is too close. So we'll just let's just move it. Yeah, let's try that. So let's try the design run checker again. Run it again, and that's it. It's fixed. Now we've got no errors and we've got no warnings. Perfect. Everything works. Okay, so we can save this. Just save that. So now that's actually saved with copper tracks. Now the other thing we can do is look at turning off layers and seeing individual layers. So hide all layers, basically end up with a blank board. What you can do is you can just look at the top copper. This is just the top copper, and you can see basically all of the tracks that we have on the top layer, which is pretty cool. And so on. So I should be able to switch layers here. Just turn off the top. That's just the bottom copper. So everything on the bottom of the board. If you like looking through the board as if it was a transparent board, we're looking through to the bottom from the top, and you can see all the wires here and everything. Put the top and the bottom on together. You can see how they all connect here, like how a red converts to a blue, how a blue here converts to a red from top to bottom. There you go. Then we've got different adhesive layers which we're not using at the moment. Then you've got front silk screen. Now you remember we'll put the text in on the top board, but we've also got all this, so this is good. We've got all the reference designators, R2, C1, C10, all that kind of thing. The chips, U1, well that's the 6502. So when we actually come to populate the board with components, when we get the boards back from the fabricator, you can tell which components go where. Basically you have a list of components, and R2 would be a particular value. You stick one in and off you go. I'll turn all the layers back on again, show all layers. There you go, so we're back to there. So what I would need to do now is put in the 4 corner mounting holes, which I should have done earlier, never mind. Once that's done, we can we've got a choice. We can either leave it like this, which is pretty good as a prototype, because if you think about it, when this goes to the fabricator and it comes back again, if you need to make any changes like cutting tracks and stuff, or putting in wire links, and there's usually 9 times out of 10, if it's the first pass of the board, there's something that you'll want to change, or there's been a mistake. It's probably better to leave it like this with easy accessible tracks, where you can just cut them with a standing blade or put in a wire link or something. It's easy to work on. However, if this was a final board and you were happy with it, maybe it's gone through 2 iterations and the first one worked perfectly or whatever, or you figured out all the errors out, you may want to introduce a copper plane on the top and on the bottom, which gives us, instead of this just being all blank area, it turns it into a copper area, and it means that it reduces board noise when you're working with high frequency components like clocks. It's a good idea to have that, and it also gives us a really solid ground plane for earthing. So it's a worthwhile process, so let's have a go at that. Yeah, so what we need to do is select an area and mark that up, and we'll tell it which layers we want. Well, we want it on the top copper, and we want it on the bottom copper as well. So you're basically selecting the top copper layer here and the bottom copper layer. Okay, so let's do that, and I'll just have to zoom out again to do that. Let's select that, and you'll notice it's colorizing the area. Yeah, that's done. Now what it's also done is put like a sort of a hash sort of shape around that, and that's telling us that this is all filled in. Okay, that's what it's doing. So what we need to do now is tell this what to connect to, and we want to connect it to ground. So in order to fill this in with all of the unused areas as copper, right hand click I think it is, and go to zones, and from zones we need to fill zone, and that's what it's doing right now, and that's it. Now let's just come out of here, you can see now all this red area, because we're looking at the top of the board. All this red area is now copper on the top of the board. It's filled the whole thing in. There's a few gaps between the chips and a few things here and there. That's not too important. It doesn't always get it perfect, but that's pretty good. Now if we close down all of the hide all layers and just look at the top copper, and I'll zoom in a bit, you can see kind of what it's doing here. Here's an example. Here's the track here, and you notice there's a gap around the track, an insulated area all the way around the track, and indeed around the pad as well. And that's exactly what we want. So if you look at the ground pin, which is normally connected to ground here, you'll notice it's got these sort of connections which is taking this pin to the ground plane copper that we've just added, which is great. It also acts as a thermal relief. When you come to solder that pin, there's less thermal connectivity to the copper, so it doesn't suck the heat away so fast, and allows you to make the connection a bit easier with your soldering iron. But anyway, that's the top layer. Let's have a look at the bottom layer, and pretty much the same. You've got things connected to ground. This is the underside of the board now, and all the other tracks have this black insulated area around it, which means it's isolated from the earth. Let's put all the tracks back on again, show all layers, and now we've got the whole picture, the whole thing. I'll save that. Now what we need to do now is another check, because when you do things like this, and you've added a copper plane, we may have broken something, or possibly we've lost an earth pin or something like that. So we need to do the design rule checker again, and just run the DRC there and see if we've got any problems. Well, in this particular case we've got no errors, and we've got no warnings, so looking good. So let's close that and get back. According to the computer, to the software, we don't have any errors. Now if you look at it closely, you see this, where you've got like a bit of a clash going on between the silk screen of the of D4 there and of D3 diode value, and it's probably a good idea you can click them and you can just kind of give them all a little bit of a nudge, and sort of get them out the way. But to be honest, that would probably work. You can see that that's D4, and that is a 1N5711 for that. So when you've got clashes like that, you just separate them a bit, just to make it a bit clearer. Now the design rule checker didn't pick up on that, so you still have to rely on your human eye to just kind of go in. There's a 1 there. It's a right old mess. Look at that. So let's shift him there, and let's shift him there, something like that. R6 there. You'll notice it's doing the references twice. It's got them underneath the part, and it's got them on the silk screen, because when you remove one of the layers, when you print the board, you only get one of these, you don't see them both. Let's keep looking for any dodgy artwork here. C3 is a little bit scrunched. Let's take care of him. That'll do. It's good enough. Just nudge it across a bit. There's any more, and you just sort of like work your way through. Make sure there's no print on top of print, that kind of thing. As long as you can tell them apart. I could maybe nudge him if, there you go, it's even better. That's D4. So really all that's left now is to put in the holes for the corners, for the mounting holes, and I normally use a M2.5 hole, through plated hole, which also connects to the ground plane, and also acts as an earthing point if you want it that way. Yeah, it's looking pretty good. Now at this point, except for the holes in the corners, I'll do that in a moment, but at this point we appear to have a fully connected working board. Yes, we could do something with the power rail, which is this pin here, pin 2. You'll notice there's a red track going up there, and there's a red track going down here. Top copper. These should really be a bit thicker normally. I'll do that again later as well when I come to fine tune the board. Things like that, power rails, good idea to make them a little bit thicker. But all the connections are now there, and according to the design rule checker, run that, we'll just run it again for the sake of it. It's coming up with 0 errors, so it means that there isn't any missing connections. All the grounds are there, all the powers are there. There's no track violations, like something being too close to another track, possibly going to short out. It looks to be okay. So far so good. There has been occasions when I've done boards like this and the top copper wasn't connected through to the bottom copper in certain areas, like round here. Like if this was, say, a ground, like here, and this area here wasn't actually connected to ground, I don't know if you can see that, but this little bit of copper here is not connected to anything, just goes to this pin. So if we go right, you'll see it comes through here, and it comes through to this ground pin on this chip, and then it comes through here and it connects to this area of copper here, which is actually a big chunk of copper, which is probably earth. So these are connected, but there are times when you have to insert vias, like stick some vias in here, stick some vias in there, and that connects the top part of the board to the bottom part of the board, so then you get your ground connection back. But you would know if there was a problem, because the design rule checker would tell you that that pin is not connected to ground. So it kind of tells you that, and all you got to do is put in the vias to connect this blue area, which is the bottom copper, to the top copper, and that usually sorts it out, as long as you've got earth underneath there. So you really have to go in and be careful and just make sure everything is connected. Rely on the design rule checker, trust it to be accurate, and follow what it says. And if there's something not connected, then go in and sort it out. The AutoRouter isn't always 100%, but it really cuts out a lot of the work for getting all the tracks where you want them. This would have took hours to just sit and route every single track, and it probably wouldn't have been as neat as that when it was finished. So yeah, you've got to go in and still make a few tracks a bit thicker and what have you, but generally speaking, that's like 90%, 95% done. Pretty good. So what's next? At this point, there's a very nifty tool built into the PCB Editor software, which allows us to look at the finished board before it's even made, before it's populated in a 3D view. And that's up here. If you go to view, there is this option here, which is 3D viewer. Okay, let's click that, and I'll just zoom back out again. And this is an actual graphical representation of what the board will look like when it's finished and populated. Pretty cool. We've got the green lacquered top copper area, and you can see all the tracks running between the pins. We've got capacitors here, we've got chips, these big chips here, other capacitor, got some resistors over here. It's all pretty cool. And there's our text that we put in, that'll be on the top silk screen area. There's our header that we're going to connect to, that's the reset capacitor here. And of course what we can do is get hold of this and turn it around. It's a completely 3D representation. It's really rather wonderful. You can tell if things are getting too close. If maybe if you've got power resistors, you might want to just sort of see the case of the power resistor, make sure it's not too close to another component, like a capacitor, which might damage it or something. So, and then we can flip the whole board over, and now we're looking at the underside of the board, and you'll notice that the mirrored text that we put in earlier is correct. So that's telling us that we did that right. You can even see the pins sticking through the holes, which is quite funny, because nothing's been soldered. So that's all quite funny, yeah. But that's good fun. And you can see the via pins. Yeah, there's the via pins there. There's a few here. There's a couple over here and what have you. I think there's 10 in total, according to the AutoRouting software. It said there was 10. Yeah, so this is actually, it's not just a toy. I mean, to me, that's actually quite, it's a useful thing to have, being able to view the board in 3D. You can really get a feel for what it's going to look like when you make the board. For instance, there's a bit of space down here, there's a bit of space over here. It's like, well, we could have maybe compressed these a bit further, and you can always go back and redo the board again, before you send it off to the fabrication to have them made, which of course costs money. Very nice indeed. So that's the 3D view of what the board would look like once it was actually fabricated. Okay, so we've gone ahead and finished the board. At least I think it's finished. I've spent about another hour on it, roughly, just going through the finer points, moving things around a little bit, like the labels and the text and what have you. But the main improvements to finish the board off is we've added the mounting holes. They're like M2.5mm with a pad around, so it actually gives you a ground point as well. The other thing I've done is if I take off the back copper, you can see we've uprated the positive rail. This is the VCC plus 5 volt rail, and you'll notice that these tracks are noticeably thicker than the signal tracks. So we've uprated the 5 volt rail which comes through to the chip there. When you put on the back copper, you can see that it continues on the back side of the board, again uprated to drive that chip, and then we'll come through this track here, which is uprated all the way through to the processor. So this is coming all the way through to the processor, which is it's a better design. It's given us less resistance in the positive rail. Yeah, and that comes all the way through, and it comes down and drives these two 74LS00s as well. So we've uprated the positive rail. You're good for like 100 milliamps or something like that on these thin tracks. These would take about 100 milliamps, probably 50 to 100 milliamps, no problem at all. But you know, it's nice. These tracks here will take a good 200 milliamp or so, 300 milliamp, no problem at all. Everything's looking pretty good. If we turn off all the layers, hide all layers. Oops, wrong one. Hide all layers. That's the front copper as we have it now, and it's all looking pretty good. That's the front copper, and take off the front copper, put the back copper, and again, all looking pretty good. Show all layers. Now the thing is, once you've done all this, and I've redone the fill all layers as well from zones. If you go zones and then fill all layers, that just makes sure that the copper areas are all filled in within the correct gaps to the tracks. Okay, so that's all done, and we'll just zoom back out a bit. If we go to the design rule checker, you must actually run this just to make sure everything's correct. So let's have a look. Run DRC, and how we're doing. Well, that's wonderful. So we've got no errors and we've got no warnings. So everything is connected. All the gaps are within tolerance, and we're looking good. But generally speaking, this is a board that we can work with. I don't see any major problems anymore. All the footprints are correct, and the rule checker is checking it against the circuit diagram. If we go back to the schematic, just by clicking this button up here, which is all very nice, we can go straight from PCB to schematic, and you know, we can check everything's correct. You know, all the power's connected and everything. We can now plot. Select plot up here, and we can select which Gerber files we want to output. You don't necessarily have to have all of the layers on. You know, you've got the fabrication layers. The fabrication layers are really so you can put the components on. You don't really need those, but you may want to print those out separately later. So there's a bunch of output files. The output directory, make sure we're going to send it to the right place. And what I'm going to do is I'm going to call this, give this a new folder, and call this Gerber. Okay, and this is where we're going to put it. So select folder, Gerber. Yeah, that's fine. And so that's where it's going to go out to. So we can also generate down here. You'll see it says generate drill files. That's important. So you need to actually do the plot to produce the Gerber files, but you also need the drill files. So I'm going to do the drill files first, and generate drill file. Yeah, let's do that. That's good, it's done it, quick as a flash. And then you do plot, and this is actually producing the, well, it's done already. It's produced the Gerber files. There is a run DRC, but I think it just does what we already did earlier. Well, we'll do it again. Don't think we need to. There you go, error free, wonderful. And actually, we're done with the PCB design. We can now close all of that, and I'll just shrinkify the screen. Right, so next thing we need to do now is check out the Gerbers. Let's go back to there and have a look at the Gerber viewer. And this allows us to check out what we've done. So we need to load in the we'll need to load in a Gerber. Okay, 6502 project, yes, Gerber, and we've got loads, so we'll just load them all in, whatever. Let's just load everything in. Cool. So here we are, and you'll notice on the right hand side we've got a bunch of layers, and they've all been given a name. Adhesive, you've got the solder mask, the silk screen, or that's the front copper there. That turns on and off the front copper, and then you've got the back copper. Yeah, that's all good. So there's a bunch of layers down here from 16 onward that we just haven't even used. You can have a lot of layers, but we're only using a certain amount for this project. 2 layers, in fact, with on top of that you've got your solder mask and what have you, and silk screen. Okay, so let's get out of here. You can have a really close look at the track construction. Everything looks really good. It's all correct. And I think we should be able to hide all layers and start to show individual layers. So I'm just going to put these on and off one by one. That's the back copper layer by itself. Looks fine. That's the mask, solder mask. Some of these don't have anything in. That's the text on the back of the board in mirrored silk screen. That's the board cutout, the edge cutout. Some of these don't have anything in. Courtyard, which is basically where the components sit. And front copper, that's our front copper mask. You'll notice they've used different colours, just to confuse you a little bit. That would normally be red in the designer. Well, because we're looking at Gerber files, it's decided to make it green. There you go. And that's the fabrication layer. I'll just zoom in a bit, hope you can see all this. That's the fabrication layer, and that's basically what you would use when you come to construct the board. You look at that and your parts list, your BOM, your bill of materials, and you put the board together using these references. Front mask, that one's got nothing in. Some of these don't have anything in. Silk screen, that's basically the front silk screen, which gives us the reference points, and that's it. So there's a lot of these don't have anything in, and I'll just switch them all back on again. And of course we've got our drill plotting files as well, which don't show up here. That's for the guys in the fabrication factory, so they know where to drill all the holes. When you supply your Gerber files, you also need to supply the drilling files, the DRLs. KiCad projects go into the V2, which is the one we're working on now, and here's our Gerber files. And inside of here, you'll notice, I'll just zoom in. You'll notice we've got lots of Gerbers. The .grb, beg your pardon, .gbr Gerber. These are all the layers of the boards, if you like. There's a job file which actually we didn't need to save. That's for our purposes. You don't need to include that. There's another Gerber down there. But the one that they need for the actual drilling of the board is these 2 files here, the DRLs, and these must be included. So what you can do is, this is one of the very final processes, is select all of these files and compress them, and then we can send to an archive send to compressed zip folder. Okay, so you send that. Basically, you're going to zip them all up into a single file, and that's it. So this zip file, okay, is actually the file you would email or upload to the fabrication house. Normally when you go to the website of the fab house, they normally have a process where you set in various things and you tell them how you want your boards made. This would be a double-sided board with pretty much all default settings, everything else, and at the end of the process it will say upload your work, upload your files, and this is the file, this zip file, which is all these Gerbers and the DRLs. That's the file you would send to them. That tells them exactly what you want: the board layout, the tracks, the vias, the size of the board, the drills, the size of the drill holes, the positions of the drill holes. Everything is in here. And if I double click that, it just expands to what we already had before. That's just the contents of the zip file. Go back to the PCB. That is pretty much the whole process from schematic to board design to sending it to the fabrication house, and that's been quite a journey. So what would happen there after that? You would pay your money. They would tell you how much it's going to cost. There's some good fabrication places over in China which are doing these boards very reasonably priced indeed. You don't have to spend hundreds of pounds or anything, and you can get them in low quantities, like minimum of 5 boards. I don't think they do one board, although somebody might do one board if you look around, but it's a good idea to get a few printed anyway, get a few boards made in case you make a mistake. You've got a fresh one, you can start again. So it's not a bad idea to get a few made. I usually go in minimum quantity of 5, sometimes 10, depends on the project. But you can get hundreds made if you're confident and you've got a proper project that you want to make lots of. You can get any amount you like. So I hope this has been useful. I'm quite looking forward to getting it back. I'll probably go through the process and get this ordered, and then we'll put some parts on, and then we'll really power the thing up and see if we've got a working unit, which would be wonderful. So thanks very much for watching the whole process. And let's leave it there, and good luck to you all. Thank you very much, and goodbye.